Hey everyone, our first video is looking at graphing motion. You've done for your summer assignment a background reading and things like distance and displacement and velocity, the basics of motion. We're going to be applying this to a visual form of looking at how objects move over time, okay, using graphs. And as we use these graphs, we have to make sure we know how to both read them as well as interpret them. First, some things you need to know. To be honest, I'm not really going to go over the definitions of these 5 items. You should be able to give me a decent definition right now. If not, to be honest, you should pause your video, go back and do that summer assignment reading. Okay, that is important stuff. The only thing I'm going to add for a few of these are some of the mathematical symbols we use because we're going to see them coming up. Okay, there's position. Position is an important term. There's a difference between distance and displacement. Displacement, so you know, is often given the symbol delta x. Okay, delta means change in. X usually represents position. So displacement is change in position. That's a definition. For average velocity, that's usually given the letter V, V for velocity. You might see it with this little flat top on it. That's the symbol for average. You won't always see that though. I'm going to take that off right now. The mathematical symbol for acceleration, average acceleration, is A. That's easy. Again, sometimes you'll see a little hat. Again, you won't always though. For graphs, this should really be review. If you have a function, there are several ways you could write it. I have it written here in a slope-intercept form. M represents the slope. B represents the y-intercept. The slope of any line segment is the rise over run. Okay, the change in the y-axis, that's the vertical. You divide by that the run, the change in the x-axis, or the horizontal. Okay, or written mathematically, it's the change in y-axis divided by the change in the x-axis. So our first example, let's say I have a graph of position and time. So I don't know, maybe this is you walking to school. You started off at position 0, okay, the front door of your house, and over time you started walking. You got further and further away from your house. Let's see, what do you think is happening right here? You've stopped moving. It's like maybe you've come to a stoplight and you have to wait. So, oh man, you're waiting. You're the same distance away from your front door. Turn green, you're able to start walking again. All right, we're going to look at the slope of one line segment. Let's just focus on one for the moment. This one right here, this very first one. If I was looking at the slope, again, that's the change in the y-axis divided by the change in the x-axis. For this graph, this is a position graph, okay? Someone's location. Well, that symbol is x. I know this is a little confusing. It's x because the y-axis is x. So I'm looking at the change in position divided by the change in time. Well, that's kind of interesting because the change in position divided by a change in time is by definition the average velocity. So by definition, what I have here, the slope of a position versus time graph gives you the velocity of the object over that time. So if we look right here, the slope is constant, it's a straight line, and it's a positive slope. So here you have a positive and constant velocity. Just by looking at this graph, that's all about position, I can tell the object's velocity. Here, what do I notice? The slope is 0. So that means the velocity is 0. Here, the velocity is also positive. But notice it has a lower positive velocity than right here because this slope is a lower amount. The slope is smaller, it's more shallow. So in this case, the velocity, just based on the definition. Next example, a velocity versus time graph. Same thing, okay, on the right hand, slope is always going to be the change in the y-axis divided by the change in the x-axis. Now I have the velocity over time. This is like pretend you're driving your car on the freeway. So right now you're going, I don't know, maybe 50 miles per hour. Okay, just pick a number, or I have units here. Let's say you're going 50 meters per second. All right, you're going 50 meters per second, 50 meters per second, 50 meters per second. Oh, uh-oh, up ahead you see traffic. You lightly apply the brakes, and over time you slow down. Well, if I again looked at my equation right here, the slope, the change in the y-axis, that's a change in velocity. The change in the x-axis, that's change in time. What is defined as the change in velocity over time? Acceleration. So the slope of a velocity versus time graph gives you the object's acceleration. Here, since the slope is 0, the acceleration is 0. What's the slope here? Is it positive, negative, or 0? It's negative. So the acceleration is negative. And that makes sense because if you're moving at 50 miles per hour and you have a negative acceleration, you would be slowing down. So, our key ideas here. If you are going from a position to a velocity graph, let's say you're given a position graph and it's asking about velocity, or it's given a velocity graph. It gives you a velocity graph and asks you about acceleration, just like my last two examples. All right. The slope tells you the next order, so to speak. You look at the slope of position, that tells you the value of the velocity. You can look at the slope of a velocity graph to learn the value of the object's acceleration. I like to think of this mantra, slope to value. The slope of this tells you the value of this. The slope of this tells you the value of this. You could go the other way. It's usually a little trickier, and we'll get practice. If I look at the value of an acceleration graph, that would tell me what the slope would need to be. The value of a velocity graph would tell me the slope of a position graph. So we're going to be practicing going from one type of graph to another. Here's my big tip. Okay? When you're looking at the slope, you should be able to tell yourself whether that slope is positive, negative, or 0. It's always going to be one of those three. This is a positive slope, negative slope, 0 slope. And also, maybe you might be able to discern, or maybe it's important if that slope is increasing or decreasing or staying constant. A constant slope is just a flat, straight line. Or I'm sorry, it's just a straight line. An increasing slope might look kind of like this. A decreasing slope might look like that. But a decreasing slope might tell you if one of these quantities is increasing or decreasing. Okay, last thing real quick, I recommend you actually just hit pause and try this. I'm not going to really explain it very much, but let's say I give you this graph here, and I want you to draw the position graph versus time and the acceleration graph over time. Hit pause, try it, and then I'll show you the answer very quickly. All right, here are my solutions. I'm actually going to start with the acceleration graph because it's a little easier in my opinion. For the acceleration, I want to look at the slope of this graph. So let's see. The slope is constant, so the acceleration will be constant. And the slope is positive. It's going up and to the right. That's a positive slope. So I have a positive and constant slope. So for my acceleration graph, I should have a positive and constant value. It should be a straight line. Let's see, I could just go and do something like this. I'm going to cheat a little bit. Ta-da. Constant positive acceleration. For position here, I actually want to look at the value of my velocity graph. And the value will tell me what to draw for the position. The value starts off at 0. So I start off with 0 value. I should have 0 slope. That's a flat line. Here the value is a little more positive. So the slope should get a little more positive. Here the slope, here the value is even more positive. So the slope should be more positive. I'm going with ever increasing value. I should have an ever increasing slope. It looks a little exponential, maybe like an x squared kind of function. Okay, but the slope starts low and gets high. We're getting a lot of practice with this in class. Thank you very much.